Welcome to InCabin from the creators of AutoSens. InCabin supports the global community of automotive interior specialists by providing a best-in-class event experience featuring an extensive agenda across 2 tracks, expert-led roundtables, and a full exhibition of the latest innovations. Today, we are joined by 2 thought leaders from Infineon Technologies. We are pleased to welcome Martin Lass and Samir Shah. Martin is the product marketing manager for time of flight, while Samir is the product marketing manager for 60 gigahertz radar technology. We welcome both to the program today. Martin and Samir, welcome, gentlemen.
Thank you very much.
Martin, we're going to start with you here. So we'll begin the first half of our discussion. Tell us a little bit about why you have decided to join InCabin in Brussels. And then second to that, why is in-cabin sensing important for Infineon?
Yeah, thank you. So the answer is rather easy. Infineon is a leading semiconductor company and #1 in automotive. And the car interior becomes more and more a key role for car makers to differentiate. And this is why Infineon is offering innovative technologies in order to meet regulations, but also to add value to your car so that OEMs can differentiate. And in the end, this is the reason why we as Infineon are joining the InCabin Brussels to meet the industry.
Martin, you mentioned the role for car makers and OEMs. What are some of the challenges that your customers are facing, and how does Infineon help them?
Yeah, so in general, car makers have to fulfill regulations and also would like to achieve full scores at NCAP. So this has started with implementing driver monitoring systems, evolving to full occupant monitoring systems, being complemented by child presence detection, and even going up to the implementation of smart airbags, like indicated from the Euro NCAP in their 2030 vision. And the challenge is now, if you as a car maker are now obliged to actually implement such a complex system, you want to get the most out of it actually, because if you're enabled to combine it with more functionalities, more features and services, then you can offer an innovative or a very convenient or luxury in-cabin, and by that differentiate from your competition. And in the end, this is also where we see time of flight and 60 gigahertz radar as technologies meeting regulations, but also on the same time enabling differentiation for our customers.
Yeah, this makes sense, Martin, and interesting. And I know a lot of our AutoSens viewers and attendees will be curious to this. How does time of flight technology do this? What is time of flight's role in this?
Yeah, actually, a time of flight provides you, first of all, the distance information in every single pixel. But on top, you simultaneously have a sunlight robust amplitude picture, like you can see here on the bottom. And such data is used to monitor the driver, the head movements, the eye closure, or even the gaze area segmentation. So, and based on this data, you now can detect the distraction or the fatigue of a driver. So this is to meet regulations. But thanks to the 3D data, you now can add more functionality. Use the 3D data for face authentication. So it's not only about face identification, but if you need to authenticate, you need to be sure that's really only the person assigned to the feature who is allowed to do it. So using the 3D data, you can ensure anti-spoofing. So you can't cheat the system by holding just a picture in front of you for the camera. And by that, you can really offer a seamless connected car so that you get access to private data or even services. So also paid services can be made very easily accessible. So yeah, that's in the end, the benefit of the 3D data, having this available. And on top, of course, you can use the exact measurement of the eyes so that you know where they are in the car to also optimize your head-up display or an automated mirror adjustment. So that's the benefits here.
Martin, we're talking about the driver. What about the passengers? What about having friends and family in the vehicle? What are your thoughts on that?
Yeah, that's also doable. So here we are talking about a wide field of view camera positioned more in the rear mirror area and covering the whole interior. As you can imagine, the 3D data enable really a very accurate 3D body model of the passengers and following even the movements in real time. So you can really do a very accurate occupant classification based on their size and weight estimations. You also can use it to support child presence detection. But the key is that having this data, you also can ensure a very intuitive HMI. So using gesture control, not only for existing or large displays to reach them, but in the future, maybe to interact even with smart surfaces or holographs, and use your movements to switch on and off the light. So this is another feature you can add by 3D data. But 3D data becomes even essential when we talk about smart airbags. So because of your exact measurement and the positioning of the driver and the passengers towards the airbags, you can adjust the airbags, the deployment force, or even switch it off automatically. And the same is true for the seatbelt detection. So you really can use the data for this functionality to make the car even safer. And using this as well to support autonomous driving modes. Think about you are allowed to go into a lean back mode because your car is driving autonomously. Yeah, if you switch back, also the airbag has to adjust to it. So because you want to stay safe. Or of course, in level 3 type of cars, when there needs to be a handover between the car and the driver, you also have to ensure that the driver is ready to go.
Martin, before we get Samir's insights here, one final question for you with airbag applications and functional safety and highly optimized cameras. Can we help me understand the relationship there with airbags and highly optimized cameras and functional safety? Help me sort of put that together. Yeah,
sure. Exactly this requirement towards functional safety was the reason why we have developed our imager according to the ISO 26262 standard. It's the first of its kind, by the way, as a TOF imager being developed according functional safety. And on top, we offer a high resolution at a just 4mm image circle. Just to remind you, 4mm image circle is even a standard camera used in mobile phones. So you can build in the meanwhile, quite tiny modules using standard packages in automotive grade for standard soldering. And also having deployed this technology already in automotive, but also plenty consumer applications, we really have a mature technology to ensure a robust high volume production even now.
Excellent, Martin. Thank you for that. To Samir now. Let's talk a little bit about radar, 60 gigahertz radar. Let's just start, Samir. What are the benefits then of 60 gigahertz radar?
Thank you. Yeah, so basically for Infineon 60 gigahertz radar, so the key benefit is that we can achieve approximately 5 major applications inside the car, so in-cabin, by just using only one radar sensor solution from Infineon. So this radar will be placed in the so-called overhead compartment, where your rear view mirror is. The solution itself, so the radar MMIC that we have is like 8 by 8 millimeters, which is like super small, and it's easy to be fitting into the roof lining area. And with this just one sensor, you enable at least 5 different applications. And in the slide, you'll be able to see the overview. So I start with the first 2, which is the live presence detection, or the LPD. Here we can do, or let's say detect, a life form present inside the car cabin Without classification, just detection of a live presence inside the car. Can it be in the footwell? It does not have to be in the line of sight. It can be in any of the seats, in the radar, in the dashboard area, and in the footwells area. On top of that, we have then the child presence detection, where we do the detection of a live form plus then the classification. And this is a very important part, because with the legislation, you need to do classification up from 2025 onwards in order to get the full 5-star rating. And therefore, with the classification between an adult and a child is important for you to get the classification or the regulation and the 5 full stars.
Moving from the NCAP regulations, that's how radar meets the NCAP regulations. What other additional values does it add, Samir?
Exactly. So as I was saying, we have the LPD and the CPD, which is basically fulfilling your legislation requirements, right? And on top of that, then what we have enabled by using the exact same hardware, by using the exact same software in the same locations, the overhead compartment, we can enable intrusion alert, proximity alert, as well as seeks occupancy detection. So for intrusion alert, what that means is that the whole cabin or the interior contents of your car are basically protected. So anyone trying to penetrate into the cabin of your car, trying to steal a mobile phone on the dashboard or your laptop on your seat you have left behind, there will be an alert. This will be detected. And of course, it's up to the OEM then to send out alerts to your phone, honk the horn, and stuff like this. Automatically, on top of that, it's also proximity alert by using, again, the same sensor, which is basically monitoring the surroundings of your car on the left and the right-hand side of your car, about 0.5 meter both sides. And this can be, for example, used to trigger video recording, for example, so that you are actually already recording or pre-recording a person who is trying to get near to your car or trying to then enter inside your car. So this is an additional feature that is enabled. And lastly, but not least, is the seat occupancy detection, which is actually the most complex to achieve, is where you can not only detect, not only classify, but actually even localize the passenger sitting in a 5-seater car. So you will be able to locate each and every passenger in the front row or in the back row of your car. And for example, this data can be then used by the tier 1s and the OEMs to optimize seatbelt reminder systems, airbag deployment systems, and in general, knowing the location of the occupants of the car.
And just to clarify, Samir, this is all doable with a single radar sensor, right?
Exactly. So as I said, one sensor in the car, in the front side of the car, so where your overhead compartment is, that's the only hardware you need. All of these 5 features are enabled by using just one sensor. As I said, it's a very compact and a very, let's say, easy to implement, because we do not need any thermal coolants or anything like that. It's a very cool running solution and very compact. So just one hardware, one radar sensor, and you will be able to enable all of these 5 features in a 5-seater car. And also, we have looked into a 7-seater car where you have like 3 rows of seats. And there you probably would then need 2 sensors in the car. But then with these 2 sensors, you're covering a whole big 7-seater car as well.
And does Infineon, Samir, does Infineon only provide the sensor, or is there more?
So Infineon, we want to become, or we are actually a one-stop shop solution, right? So in the end, we do not only do the sensor. This is a so-called product to system approach that we have, where everything, the whole system for the in-cabin 60 GHz radar is based on Infineon components. And it's not only our radar MMIC, which you see on the slide, but also on top the microcontrollers, which are the Oryx microcontrollers. And then you have the OptiReg power supplies as well. And all of this complies in one sensor solution or one shop solution in the end. And everything is then based on the radar. On top of that, this goes for the hardware, right? So on top of that, for the software, which is a very crucial part of this offering, is where the algorithm or the software algorithm is also provided by our partner. Novelic is also mentioned on the slide. They're working, they have a very long standing experience on radar algorithms, specially designed for automotive applications, and they are our partner. And this is the demo that we are presenting at InCabin in Brussels. The software that is running on top is made by them. So it's a complete, fully fledged, fully working solution, which a customer can just outright buy.
We've been talking about time of flight, now radar. Samir, is this a case of one or the other? Should you use radar? Should you use time of flight? Or are these technologies complementary? What are your thoughts on this?
So exactly as you just said, the technologies are complementary, right? So radar has its own strengths and weaknesses, and on the other hand side, the time of flight sensors also have their strengths and weaknesses. So each technology has its benefits, but also its limitations, and they're addressing different problems. So the camera-based or the time of flight-based solution is a technology which is more focused towards driver monitoring, where you can do airbag deployment and gaze and face ID and stuff like this, where you definitely need for sure line of sight. On top of that, you need much more higher resolution to really track the movement of the eyeballs or really have 3D data available to you for different applications. On the other hand, the radar domain is more or less based on the line of sight. They're mostly are able to penetrate then the whole of the car, and therefore the applications, for example, child presence detection, where you are looking into the areas of your car which are generally hidden from the naked eye or from the camera perspective. This is where your radar technology comes into play, where it is then based on reflected, let's say, signals, so it does not need to have line of sight. Compared to a camera-based technology, radar consumes less power, so it's a smaller and a much less power-hungry solution, and is of course cheaper as well. But in the end, it also has its own weaknesses. Then it has less resolution, of course, and it cannot then have a 3D point cloud for certain applications. So ideally, in the end, it's either or for the depending on the application that you're trying to fulfill. But in the end, if you want to cover all the in-cabin applications, the ideal solution would be to have a sensor fusion kind of an application where you're using radar for it's certain, let's say, where it's powerful, and then you're using time of flight or TOF sensor where it is powerful.
This is really exciting, Samir. Thank you for your insight and a preview of your solutions. Before we conclude, do you have anything else you'd like to add?
Yeah, so I would like to thank you too as well. And I would definitely like to invite our viewers to visit us in Brussels in the InCabin. We will be there with our cool demos there, and on the June 21st and June 26th. Also, please take the chance to listen to the speech from Martin, my colleague Martin Lars, and talk to us and our experts and experience the live demos that we will have there.
Fantastic. We've been speaking with Martin Lass and Samir Shah from Infineon Technologies. Martin is the product marketing manager for time of flight. Samir, the product marketing manager for Infineon's 60 gigahertz radar technology. Thank you both, gentlemen, for a fascinating discussion. Good luck, and we look forward to seeing you in Brussels.
Thank you very much too. Bye-bye.
Thank you.
For more in-depth interviews like this, subscribe to the AutoSens YouTube channel. And for more information about InCabin, visit InCabin.com. That's InCabin.com. On behalf of InCabin in Detroit, I'm Carl Anthony.